Hi, everybody. We've already met, but they don't know that in the video. This is a talk about the introduction to Kotlin Multiplatform. My name is Kevin Galligan. I am a partner at a company called TouchLab, and I have a few decades of coding, a couple professionally. Again, on the Android thing, I was doing Android development before they had a phone, so let's say a decade of that too. TouchLab is like a mostly mobile shop, and it was an Android shop from like 2010 up until a few years ago. And then, well, we make kind of apps and weird hardware things. There's a thing called a mirror where you can like put it on the wall, and there's like workout videos and yada yada. That's based on Android. In New York, they have a tower where you can have a touch screen, and it's replaced the payphones. We worked on that too. Anyway. I kind of took a detour in my career a few years ago to basically focus on this tech, multi-platform tech. And so I don't really do any consulting company stuff anymore. It's all research and open source and coming to speak at various things. And our first partner in that world has actually been pretty great. So this company called Square, and they make a lot of open source stuff in the Android world. And they're super into multi-platform. And with them, we've actually been working mostly on making Kotlin multi-platform more appealing to iOS developers, and we have some interesting stuff from that. But we're having a library talk at 2 o'clock or 1400, which we talk a little more about the library. So what is Kotlin multi-platform? So in the native mobile world, essentially mobile developers think of things as you're either doing the native platform and language, or you're doing everything else, which is cross-platform. And that's not a precise conversation, and it's a disservice to the various pieces of tech out there. So I kind of start by giving the definition as precise as I can. And this is like the most concise definition of what I think Kotlin multi-platform is, and like what differentiates it from other technologies. So it is optional, natively integrated, open source code sharing platform based on the popular modern language Kotlin that facilitates non-UI logic, available on many platforms, right? And then this slide is like a year old, and I haven't really updated. So the other big important differentiator is JetBrains. So I'll have to redesign the slide at some point, but I didn't for this talk. So anyway, what that means is, I'm going to break this down. Optional sharing is a lot of the technologies, the cross-platform stuff, they want you to like build an app within their technology. So React Native is kind of like, hey, you can build apps with JavaScript, and then you're kind of in their ecosystem. And like Flutter's the same thing, and Xamarin's kind of the same thing. It is what we call a big decision. You have to like rewrite a bunch of stuff, or you have to write a bunch of bridge logic. It's running in its own VM. It's doing a lot of stuff like that. And big decisions are risky. And especially, I spend a lot of time talking to Android developers, and I have to sort of remind people like this, I know this tech's appealing, but the way that orgs think about things is different than maybe an individual developer, and risk is a much bigger problem for larger orgs. So optional sharing is very important. Natively integrated. So Kotlin attempts to live within the ecosystem that it's operating. So again, one of the big problems with React Native is, there's a big bridge between the JavaScript and the native environment. Same thing Flutter, same thing with Xamarin. If you want to integrate with native stuff, you got to bust out the C++ sometimes. That's not really going to fly in a large-scale environment. Kotlin is attempting to natively integrate, which dovetails well with the optional nature of the code sharing. So open source, 2019, you couldn't launch a new coding platform, realistically that isn't completely open source. JetBrains does a great job of developing in the open. So even though you don't know what their plans are in the future, you can see what they're committing and see what's happening. Yeah, I have a long talk about why this isn't just Swift for Android, but since most of you are native mobile developers anyway, we'll skip that part. Code sharing, and again, not cross-platform. I don't really say cross-platform a lot, except ironically. It's just like a term that has a lot of baggage, and I just kind of call it like a ruined term. Like you can't really say it because it just brings up, cross-platform is PhoneGap in 2012. Cross-platform is Xamarin, and we couldn't figure out the memory problem. Cross-platform is all these things. It's just not useful. Code sharing is an entirely different thing. So that's kind of all we say. And popular. And I don't mean popular in a sense that like, hey, the cool kids are doing it. That's not why popular is important, right? This is a talk I gave at Droidcon UK a year ago. Way more people showed up than I thought. Someone pointed out that if it's so popular, why are they all looking at their phones? And I said, that's because I took the photo before I started speaking. But anyway, popularity is important because ecosystems that aren't popular don't have big communities. They don't have a lot of libraries. There's not a lot of people you can try to hire. There's not a lot of training opportunity. That is the opposite situation here. This is growing in popularity significantly and very fast. And there's already an existing Android community that's large and very engaged that is converting over to this ecosystem. It's just an important aspect that you have to consider when deciding on technology. And modern. So I don't mean like the nullability syntax is like Swift, that's why it's modern. I mean that if you watch the Kotlin Conf keynote from last year, JetBrains is proud of the fact that they're not trying to go out and do completely new things. They're taking the best practices of other languages and incorporating them over time. So the language is modern and stays modern going forward. I am personally very focused on their concurrency model, which is what I'm talking about at Kotlin Conf, which is its own internal kind of battle going on in the community, but at least people are talking about it, and it's kind of interesting. So, and not UI. And when I say not UI, I mean not necessarily UI. Definitely people are going to do weird shared UI things. I think in certain silos, there's going to be a lot of success. If you want a form builder, there's going to be probably 15 form builders in a couple of years. But again, a lot of the cross-platform stuff is trying to do like one UI, everything in one big package. And I don't think that's the right way to go. I think starting from the bottom up and then sharing UI optionally or sharing up into the stack as much as you want. I don't know if this is something you shouldn't do in a talk, but I feel like quoting yourself in a talk is not a great idea, but I am. So shared UI has like a history of pain and failure, but shared logic is the history of computers, which kind of sums up my thoughts on these different technology options and why I think it's not like Kotlin's going to succeed or Flutter's going to succeed and the other will fail. It's Kotlin's going to be successful as a shared code option. Everything else, whatever, we'll see. But if you're trying to share everything, it's just a risky thing. It doesn't have a good track record. So, many platforms, and this is a short diagram of the many platforms. We'll talk about them a little later, but there's a lot of places where you can put Kotlin. And I know that sounds a little weird, but it tends to work fairly well, and we'll see. So, an IDE and tooling, that's why the end JetBrains is important. If you're not a mobile developer or an Android developer, if you're not like a JVM Java developer, you might not be familiar with IntelliJ or JetBrains. But JetBrains is, I think, the best tooling maker in the market. They've been around for decades, and they're making Kotlin and the tools around it, and they're very invested in it. So I think if anybody's going to be successful, it's them. I was, into some of these other alternate JVM languages for a little while, and none of them have like a major org that's also making the tooling, which is, I think, critical. So there's a summary. Why Kotlin? High efficiency, low risk, modern language tools, highly engaged community. That's that. Now, again, I am a native mobile developer, so we will talk a bit about not native mobile development, but that's essentially what I focus on. And yeah, you can output JavaScript with Kotlin Multiplatform. You can output WebAssembly. I'm big into mechanical keyboards. You can probably write to the controller on there with Kotlin, but that's not important. What's really important right now, the killer app, not the JavaScript's important. Like, slow down, I didn't mean that. But the killer app out of the gate is going to be sharing native mobile code. And mobile is easy. And when I say easy, I mean relatively. Because under the hood, Android and iOS are essentially like the same thing. They're both Unixy. They both have files and networking and threads and SQL. Architecturally speaking, they're very similar ecosystems. So sharing logic and architecture is very doable. And the fact that you can share some things or a lot of things means that you can do it in pieces and you can choose how much you want to do. So if you're doing tax calculations that are very complex and need to be tested like crazy, sure, you can do that. And you can just expose a library to iOS, and it's not going to be a big problem, right? So in the mobile side, at least, the first killer app is going to be, it's going to be mobile. So technically, though, great. What is it? It is, so first of all, multi-platform is a compile time construct. At runtime, multi-platform doesn't mean anything. So multi-platform is a way to represent shared code, but have it compiled down and deployed to multiple platforms specifically. And the three main targets are JVM, JS, and native. They all have, again, this diagram, many specific targets. So in the JVM, you're going to have multiple versions of Java you can target, or Android specifically, which will have all the Android stuff, like if you need Bluetooth or whatever. JavaScript, again, I know less about Kotlin JavaScript. There's sort of a browser flavor and a server flavor. I know that there's some more work that needs to be done for TypeScript to be fully compatible, yada, yada, yada. They're working on it. I don't know much about it, but you can Google that. Then native. I know a whole bunch about native. This is essentially what I do all day now, is make Android code work on the iPhone. But there's a lot of native targets, right? So you've got the phone, watch, TV in the Apple world, Mac OS, Linux, direct Linux targeting, Windows. I haven't done native Windows in 15 years, but you can do Windows there. WebAssembly, which we'll see about the future. I expected more WebAssembly by now, but we'll see in the next 5+ years. I'm pretty excited about it, but I don't know. It's taken a while. So anyway, the three main targets are JVM, JS, and native. And again, I'm mostly going to kind of focus on this world from now on in the talk, with some exceptions. So let's say you're going to make a thing. And on the native side, what happens is you have common code that defines, essentially the common logic of what you want to do. And then there's a hierarchy of source sets that will provide this platform-specific stuff that you need to implement some of those things. So if you're making a library, you could have multiple layers of code. But in reality, if you're making an app, you usually just have common and whatever the platform-specific thing is. From there, it compiles down to, let's say, an Xcode framework. And then Xcode could import it, and you can talk to that from Swift or Objective-C as if it was like another framework. If you're an iOS developer, yes, it is Objective-C as an interface right now. They're going to focus on Swift Direct Interop next year. Now there's ABI stability. But Swift has had to spend several years learning how to talk to Objective-C. So there's a lot of optimizations to make that not terrible. On the the Android side, Android and Kotlin kind of are like super friends now, so that works really well. And the one thing that's really important to people when evaluating the tech, I like to remind them is, a lot of other cross-platform options are cross-platform on both sides. For this, Android is 100% native. You do exactly what you would do in a normal situation. So there's no risk added to the Android side, which is fairly unique in this world. And then this is a good time to remind you that it's not like, hey, iOS developer, now you can do your UI kit stuff in Kotlin. It's really not how it works. You can start with just a little bit. So you can share, nobody I know in the iOS world likes core data. So you can share your database logic and then nothing else. Or you could share your analytics calls so that they're homogeneous and nothing else. You can share a bunch of stuff. In some of our sample apps, we share everything up to the UI, and then the UI is as dumb as possible. So most apps are going to look like this, where you just do all your normal things and then start sharing critical code and testing it better, things like that. So what's the status of this? Fun part about prepping for this talk, I got to look at my predictions from last year and figure out how wrong I was. So since you're not native mobile developers, and a lot of you aren't super Kotlin experts, there's this thing called coroutines. And I won't explain what that is, but it's related to concurrency, and it's very important to that world. And the native team did not have multi-threaded coroutines, which is not necessarily exciting for people that want concurrency. And there were no compiler plugins, so you couldn't do code gen, in a formal way. You had to kind of work it yourself. And I figured both of those things were going to be Q1 of this year. And then others like samples and libraries, production app deployments, yada, yada, yada. Here's where we actually are. I was wondering whether or not we would have multi-threaded coroutines at the end of this year. And it turns out that there was a pull request, or not a pull request, a branch that went in to finally implement that a few days ago. So I've spent the past few days in the hotel trying to get a sample working. But that's definitely coming, and that's a big psychological barrier. I'll talk about it in a second. Compiler plugins, JetBrains decided to rewrite their entire compiler, so that's going to take a little while. But we're about to see many threading libraries because there is that block of multi-threaded coroutines that's now unblocked. And there's going to be endless threading blog posts coming out soon. And increased production adoption. My job now is to go meet with companies that are evaluating or pushing to production, and that is happening at increasingly larger scales, and we'll do so even more so next year. Improves tooling stability, but that all kind of equates into the general concept of this is turning into a mainstream technology much more so next year. Is this ready? and that is the question I get quite a bit. And I would say that that's more about your team. Can you put this in production, and will it just spontaneously crash? No, it will run in a stable manner, right? You're not going to have odd memory leaks randomly. Like it is stable at a runtime level. Are the docs a little out of date? Do things need to be cleaned up a bit? Does like the tutorials need to be better? Like absolutely. It is early adopter phase, but it is going to be leaving early adopter phase sometime in 2020. So if this is something you want to look at, you can do it now, but you should be used to like poking around open source a bit. I can tell you that for sure. So, and multi-threaded coroutines, need to change my slides. I have like 2 other talks, I'll give you one today and then one next week, and all of them need to change because they're sort of related to that. It was sort of a psychological barrier, I think. A lot of teams were like, well, you don't have coroutines, so this isn't ready. Well, that psychological barrier is about to get like unblocked. So that is going to change. But again, if you don't know what coroutines are, then that doesn't matter as much. So let's see, what does sharing code actually look like? Again, Kotlin embraces the native of the native platform. So the Interop story is really good. The first thing that you will notice when you start is this thing called expect actual. And it's like a new set of keywords and kind of a new concept. Although someone explained to me last night that this is a lot like extern in C, but I'm like, I don't know, maybe. There's in your common code, that top thing, you would say, I expect this thing to exist. And then in your other source sets, you're going to say this is the actual implementation of that thing. You need to have an actual for every expect in your stack somewhere. If you don't, the compiler will complain, the IDE will complain, assuming you configured it correctly. This is where the tooling needs to stabilize a bit. But what that looks like is here we have expect val, is this the main thread? And it returns a Boolean, right? That's in your common code. In Android, which is on the other layer, we'll have the implementation of what that looks like on Android, which is you want to check if the looper is my looper. And then on iOS, again, in a different source file, it just does what happens in iOS. And in JavaScript, it would just be true, because that's how JavaScript works. But I left that off the slide. So you can have different structures that are expect actual. So you have values, functions, which is actually, I would argue, probably the most day-to-day useful one. Classes, and you define what should be in the class, and then implement all the things. Objects, and I'm not going to talk about this. This is more of a library thing, but you can do annotations as well. I just kind of copy-pasted that from one of our libraries. A class and an object look like this. I copied this directly from IntelliJ's sample that comes out of it. For a class, you define the functions you want to have, the values you want to have. In this case, also a constructor, which is not always the case. And for objects, similar thing. And then in here, in the common code, you can write a thing that uses this, even though you don't yet have an implementation, which is going to happen later. On the Android side, you do actual class. You have to make sure you implement everything, or it will complain and fail to compile. Same thing with the object. And then iOS, not a lot different. Are these useful implementations? They are absolutely not. But in a real example, you're going to have much more complex types and a lot more stuff going on. And there's another thing that I'll briefly talk about. It's called type alias. So if you take a look at this, this is from one of our libraries. We're implementing a shared atomic integer. So here's all the things that you can do with the atomic integer, and it has this very specific method signature, because on the JVM side, you can just do this and say, my atomic int is actually Java's atomic integer. And then you're done, because it matches that thing 100%, right? Which is actually pretty neat. Unfortunately, on the other side in iOS, you have to do this crazy thing where you pass in and you have a different delegate that you're wrapping and carrying around, because the signatures don't match 100%. And between Android and iOS or JavaScript or anything else, it's extremely rare that both sides will match 100% out of the box. So you kind of have this whole delegate hierarchy, you have all this crap going on, you have to carry around. And we're going to talk much more about that in a few hours. So we'll kind of leave that where it is, because that's not an intro level talk. So I will say, after all that expect actual, when you get a hammer, everything looks like a nail. So the tendency when you get a new tool is to overuse it. And expect actual is definitely one of those things. So every developer I know that got into Kotlin Multiplatform started doing expect actual everywhere, expecting that that's what you're supposed to do. But the reality is, It's a lot easier to share code with interfaces. So here's an example from a library called Multi-Platform Settings. And on Android, it's shared prefs. On iOS, it's NS user defaults. On JavaScript, it's whatever persistent thing you do with a map, which I don't remember off the top of my head. And it's an interface. It used to be expect actual, which is actually quite inflexible, which we'll talk about in a second. And then you're like, okay, this is an interface, and then we can use expect actual for the function, for like a factory function. Then each platform will give you the implementation you want. And then we did that for a while, and then kind of backed that out, and then we wound up with this in one of our apps, let's say as an example, where we pass in all the implementation on app initialization, and they just go into the shared service registry, and wound up with like essentially just interfaces and no expect actual at all. The reason? Because then you can do testing much easier. You can pass in mock objects, you can pass stuff like that, and if you do everything expect actual, it's much less flexible. So this is from we have a Droidcon app sample, which I'll talk about briefly a little later. But inside the Droidcon app, we have this like big central service registry that we pass all these interfaces and various implementations into, so other parts of the app can pull them out. And testing obviously does it a different way. If that feels like a really cheap dependency injection implementation, good news. So hopefully at this conference, we're going to finalize plans for implementing multi-platform coin, which we have sort of a fork and an early implementation of. So hopefully we'll have that functioning as well. So wish us luck that we sort that out. So again, here's another example of an interface. Like we have an analytics API, and inside the app we want to have shared analytics. So we have log event. The Android implementation is actually oddly complicated. We have to do a switch on type here. The mock implementation, not super complicated. It's actually quite boring. We're just deciding whether or not we call the log events. And on the Swift side, this is Swift code. And you just pass this in on app startup, and it's actually super straightforward and much easier than the Android side, which was interesting. On the Swift side, the entire setup at the beginning of the app in the app delegate kind of looks like this. We're just passing in the platform-specific implementations for like a reasonably robust app. It's doing a lot of things. That's the Droidcon app. And then the other way to share logic that we use a lot is Functionargs. And if I was redoing these slides, which I may do at some point, I would kind of put Functionargs and interfaces like in the same section, because they're doing a lot of this very similar things, and they work very similar ways. You essentially, in your shared code, define a function, and you take that as an argument during initialization, and then on either side, you just implement that with the Lambda syntax. And then Swift, like in this case, the application wants to load with seed data. So the way we do that with shared code is we have this function that says, here's the file, here's the type, give me the shared data. And on Android, it's in the assets folder. On iOS, it's in a bundle. And we just pass this in the initialization of the app. So it's very easy to like reach out and do platform-specific stuff. One note about that, it is somewhat harder to test. And I mean not unit tests, because obviously if you're doing unit tests, you don't want to be necessarily pulling files from the devices folder. You want to be mocking that out somewhere. But if you're doing sort of higher level tests where you want to actually test a platform-specific logic, that is difficult because the way that Kotlin produces an exe that gets run, and you need to like actually bootstrap this with XC test, yada, yada, yada. Just be aware that there are things that are more difficult to test using these techniques. So this is the Droidcon app. The other weird thing that I do is I kind of run Droidcon New York. So we made, I think, one of the first multi-platform apps published into the App Store. And it is a conference app. And it's been now a year and a half that we've been working on this. It is desperately overdue for a refactor, which is going to happen December, especially now with multi-threaded coroutines. I tried to get a multi-threaded coroutine branch compiling before this talk, but that's not going to happen until next week at least. Check this out. It is a little complex to kind of follow. And again, yeah, I think we were the first multi-platform app in the App Store, but we'll see. So no expect actual. I would say that you want to kind of minimize it, right? So just be aware that just because there's this new keyword set that it doesn't go everywhere. Just don't go through that phase of your Kotlin multi-platform learning. for example, the Droidcon app's got 9 functions that are expect 2 classes. It could probably be less functions than that. We just haven't gotten around to pulling them out. And the classes are like date classes, so it's kind of convenient to wrap stuff like that. On the flip side, you know, we have a library we're going to talk about in the next talk where there's 100+ instances of expect, and it just depends on what you're doing, essentially. So getting started, I would say the Droidcon app is okay, but there's like a lot going on. So if it's the first thing you look at, it's going to be kind of difficult to follow, to be perfectly honest. There's this big JetBrains Dock that walks you through what multi-platform is technically, and then a whole bunch of stuff in there. But it also talks about, like, you know, if you want to build a Linux, you know, command line tool, or you want to, you know, it's like a lot of stuff in there you're probably not necessarily going to want to do. Just be aware that it is complete, but that's good and bad. One of the issues that we found in the community right now is that there are a number of tutorials, but they're out of date very fast because everything moves very fast, and people aren't really maintaining them. So if you want to get started, it can be very difficult. We talked to people that, like, they started reading something, and then, you know, the following day they were still like trying to get the tools set up. They were still trying to get their configuration set up. The Gradle thing wasn't working, yada yada. So Ben and our team has a series of articles called the 5 minutes, and the first one is essentially as long as you install these tools, it should take you about 5 minutes to clone and build and see how shared code works. So go take a look at that, and then there's another one about how to add a library, and we're doing another one about how to build libraries, hopefully in the near future. That one's longer than 5 minutes, to be honest. And we're maintaining those, like committing at least till Kotlin 1.4. So as soon as there's a new version of Kotlin, we update the thing, so they're consistently up to date. Probably the most important thing to do is go join the Kotlin Slack. The JetBrains team is there. A bunch of people are in there that are very helpful. I am there. You can reach out, and I will actually help you directly if you're having questions. It's obviously very important. The other thing we are also doing as an org, my consulting company is essentially pivoting to try to build our future around this tech. So we're doing a bunch of stuff, and we've talked to a number of orgs that are evaluating. And usually what that means is they'll have someone on their team and assign them, like, hey, do a hack week for multi-platform, and they'll find all these tutorials that are, you know, mutually exclusive, and they'll try to do things like, let's take our production apps and try to do some shared code in our production apps, even though they're not iOS developers. And one in particular, it was like, well, I got to Thursday before I could compile anything, and then I wrote a blog post to our team that was essentially like, hey, the tech's not ready. And I'm like, well, maybe, you know. So what we're doing is this kit where it's just a set of prototype repos, depending on the kind of stuff you want to do, and you clone them, and then a series of getting started documents and explaining the necessary things you need to have. Essentially, like, it's like, hey, read all this and get through this part to get it set up, and ignore everything else until you get to here, and then you can read all the other blog posts you want. But it's trying to accelerate that evaluation period. So my marketing geniuses have called this the camp kit, which we'll see how long that name sticks. And we have sort of the space theme, but this is a camping theme. I don't know, yada yada. This is also December timeframe, so I would say mid-December. But go here and sign up, and you can get information about that. So the other thing that you also need to know if you're going to do this is Native has this new concurrency model, and a lot of people try to get started and just say, well, I'll figure that out when I get there, and then just hope that they don't have to worry about it, and you absolutely do. If you don't learn the basics of it, you're going to have a real problem, right? And the basic thing is that mutable state is one thread, and immutable state is many threads, and there's this new state of state called frozen, and you can freeze your state, and that's how you can share it. There's actually a function that you call on state that makes it frozen, and we're absolutely not going to talk about that today because it's way out of scope. But you absolutely need to understand that, or you will not be able to do anything productive on the native side. JavaScript doesn't matter because you're not going to be sharing state with threads. So there are JetBrains links. They are, again, complete, but they're a little dense, kind of advanced. Actually, the last one was Kotlin Conf last year. The lead of Native talked about the model, but again, I would go back and watch that once you understand the basics. To understand the basics, I have this series of blog posts that I have cleverly named Stranger Threads, which goes through the basics of that. And then I'm, in a few weeks, back in Copenhagen to talk about that state model in far more detail. But it is a critical thing that you need to understand in order to do anything productive with Native. And that is my talk. You can get more information, get me on Twitter, you can get me on the Slack and do whatever you need to do. This is not a US audience, but we are aggressively starting to hire to get more people who are interested in this tech. We are remote, but currently not remote outside of the US, although I'm working on the legal aspects of that. That is it. Does anybody have questions? Yes? Okay, so the question is, well, what about RxJava on the native side? If I could summarize, yes? Okay. That is, it's a multifaceted answer. So is there a port of RxJava that works in Kotlin native? There is. It's called reactive. There's a K in the name because everyone has to put a K in a Kotlin name. There's a developer from Badoo who works on that. You can use it. It does work. However, it does mean that you would have to swap out, your Rx code for that code and buy into that ecosystem. I think everybody in the Android world is essentially moving to coroutines. So Rx stuff is probably, for concurrency, Rx stuff's probably moving to Flow. I don't know if you've ever done anything with it. Okay. So that's essentially where most of the Android world is. Let me rephrase that. The Android world that goes to Android conferences certainly talks about that. I don't know how much it's actually happening in reality, but JetBrains is pushing that, and multi-threaded coroutines, as I said, like quite literally, Kotlin X coroutines has a branch that has multi-threaded coroutines for native. And that's going to be releasing in the next version of Kotlin. So that's where everything's kind of going. What happens after your shared code and how that propagates to your platform-specific code is, like right now, that on Android it would probably go into like live data. What happens on iOS is a little bit undefined. And I don't have a 100% clear answer. Are there like many people talking about it, and are there many like half-baked solutions coming out in the next few weeks? Yeah, and then sometime next year I'm sure there'll be something that everyone starts using. But it is a common topic. But you're definitely not going to be able to just take Rx and directly use it. So, does that answer the question? Okay. Sadly, yeah, Flow's cool. I have, you missed it, because before the Kotlin Multiplatform, I did this whole ecosystem with J2OBJC, and I actually got RxJava 2 working in J2OBJC, which was a complete nightmare, but it worked. Yes? How does debugging happen? Well, if you remember that slide where we had our partnership with Square, I actually wrote an Xcode plugin that you can visually debug Kotlin in Xcode. So that's how it happens in Xcode. I don't know. It works, though. Oh, I don't know. I have no idea. I mean, it's all LLDB based. So like if you have a plugin that does LLDB debugging in Visual Studio, then in theory it should work. I know someone did like the VS Code, but I haven't used it. So we have competing pull requests into Kotlin native with LLDB formatters. So at some point that's going to get merged, but it's all LLDB based. So there's probably a way to do it. Anybody else? No? All right. Well, I'm speaking in a little while about libraries. That one's going to be compressed for time because it goes into far more detail about how to actually do this stuff. But thank you for coming.